Hey guys, welcome to my YouTube channel. So myself Rohit, I'm an enterprise wireless engineer. So as you guys know, this is a playlist where we are continuing studying the semiconductor physics. So in the last previous classes, we have individually gone through the formation of energy level, then from energy level to band formation, then from that P type, N type, and then junction of PN. Then now we are getting into some more fundamentals like how the individual drift and diffusion current is happening. So we already gone through the drift current, that is drift velocity we have gone through. So now we are going to extend the same into the drift and diffusion current. So let's take first one as a drift, then we will start into the diffusion. So drift as the same as the velocity, drift velocity, how it is happening. So when there is an external electric field that is happening, or that electric field may be happening because of anything like internal or external, that may not be our that our concern. So that is there happening some kind of electrical field change. So the charge carrier moves in the influence of electric field. So this is what the drift current will produce. So when a charge carrier maybe N or P anything, so moves in the influence of electric field. The electric field may be internal or external. That term may be quite confusing. The internal and external. So I will explain you. The external electric field is the case when we are connecting the semiconductor material to some kind of external supply like 5-volt battery or a 12-volt battery, that may be. So in this case there will be some electric field production that it is will aligned from positive to negative. So that is what the external. The internal is somewhat quite different. Due to the external electric field, there will be some movement of electrons and holes. Based on that, there will be production of some internal electric field. So that we will discuss while going through the diffusion thing. So this is what some quite difference between internal and external. So then it is called as the drift. So when a charge carrier moves in the influence of in the influence of electric field, then it is called as the drift. So let's take an example that if an electric field is in this direction, then the electron will move in the opposite direction. Then the holes will move in the same direction of applied electric field. If electric field is in direction, electrons will move in this direction, then holes will also move in this direction. So this is an electric field E. This is the electron drift. So the term is drift. So here the term holes drift. So here the holes drift. So ultimately the net electric field will be in this direction only. So I net will be in this direction. So which is equal to IN plus IP. So that will not be changed. So this is what some quite thing. So now let's get deeper into how the drift electric field, the total electric field formula, and the drift electric current density, how that is defined. So let's take an N-type material of the drift. So we have to mention because there is a due to electric field drift. So what is the formula of that? Which we already gone through, which will be NQ mu N EA. So this is the formula. The unit will be ampere. That's a unit of this. So if you take Jn, so Jn drift. So we know that it is an area which will be divided by. So J which will be In divided by A. So we can remove this A from here. So then that formula will be NQ mu N E. That's it. Then A divided by centimeter cube. Sorry, centimeter square because it's an area. Why taking centimeter is that in semiconductor we will not consider meter. The thing we consider EV instead of joule, right? So similar to that, we will consider centimeter as the unit thing. So this is what it is called as the electron drift current. So this is electron drift current. So similar to that, it is called as the electron drift current density. So density because it's divided by area. So electron drift current density. I hope it's understood for you. So similar to that, it will be for IP. So IP drift will also be similar. instead of n it will be p. So that is the free charge carrier based on the free charge carrier. So pq mu p ea. So this is same ampere. So this we called as the Hole's drift current. The Hole's drift current. Then if it is divided by area, then we will call as the Jp drift. So this can be called as the PQ mu P E. So this will be A divided by centimeter square. So this will be called as the Hole drift current density. Hole's drift current density. Hole's drift current density. So let's take about the total. So there will be, if you take a semiconductor, then there will be a total current produced by both the charge carrier. So that will be total J total. So which will be equal to Jn drift plus Jp. If we are considering only drift here. So then the net formula will become as the Nq mu Ne plus Pq mu Pe. So if you take the common term outside, then we will get Nq mu Ne. So E we will be taking outside because it is a common here. So plus Pq mu P. So let's take E outside. Then this is what J. So J we can simplify that to sigma E. So sigma is nothing but here that is the conductivity. So this is the Ohm's law. In electrical conductivity we state this as the Ohm's law or Ohm law, not as a Ohm's law. There is a chronological name change. We call this as a Ohm law. So note that the drift current depends on the carrier concentration and electric field. So this sigma which is equal to Nq mu N plus Pq mu P. So this is what this is the because of conductivity due to electron. This is the conductivity due to holes. So this is what the drift and drift related formulas are dependent. So let's take the second term where diffusion. So diffusion is not based upon the external or internal electric field. So let me give a small introduction, and from next class let's get deeper dive into formula. So when a charged particle moves due to difference in concentration or due to gradient of slope, then it is called as a diffusion. So let's clearly understand the term. So when a charged particle, so the same thing, the movement of charged particle is contributing to current. There is no change in that. So when a charged particles moves due to difference in concentration, like when we are doping, there is not a constant doping, that there is a huge difference in the doping. So because of the difference in concentration, the difference in concentration we can also state as the concentration gradient, both are same, or due to concentration gradient, these both terms are same. Due to concentration gradient, gradient means some changes is happening there, that may be negative or positive. The slope of difference may be different, that is not an area of interest, but there is some concentration gradient that is present there. So concentration gradient, then it is said to be diffusing, then it is said to be diffusing. Okay, I hope it's understandable. So from next class I will be drawing a diagram and I will be explaining the diffusion current thing. So stay tuned for the next lecture. Like, share and subscribe the channel. Thanks for watching.